Welcome to another webinar on Rig Recon University. Thank you for joining in today. Today's webinar is going to cover LED lighting. Now, we've covered LED lighting before, but in the past when we covered it, we really went into the science of lighting and where LEDs came from and how to tell them apart. Today, we're going to talk more about functional lighting solutions and putting the light where you need it on scene so that you're using it properly. Our overview of our agenda today quickly is we're going to go over some terminology. We can't get completely away from the science because it's critical to know the terminology to be able to compare these things to each other. Or they're going to refer to a subject that I call purpose duty lighting. And I'm going to refer to that several times throughout this presentation. The whole point here is defining ahead of time, what do I want to do with the light? What am I trying to achieve? And then picking a light that's going to achieve that goal. Instead of just saying, I want the brightest light where it normally is in the side of the truck and it lights up everything. We're going to talk about intensity some. Fire service, the biggest is the best, right? We want the biggest pump. We want to pump at the most pressure. We want the tallest ladder. Not always true. There's give and take in everything we do. So we're going to talk about that intensity debate and is there such a thing as too bright? We're going to get into some new tech, really look at what's out there on the market that you might not be aware of. And then you've got a lot of choices in the industry. We're going to show you some ways to break those down and look at them cleaner where it's easier to understand. So let's start with our terminology. We can't get away from understanding how some of this lighting works. When we talk about an LED light, we talk about lumens. Lumens, the definition is it's the total amount of visible light emitted by a source. In other words, it's how bright is the light. Now, what's very misleading about lumens, we're going to get into raw lumens versus effective lumens. We're going to talk about how do I look at lumens. Just think of lumens as the brightness of the light. In many sales pieces and literature and pitches, you'll hear about lux. Why do we even care about lux? Well, lux is something I can physically measure. I can take a light meter and it's measuring in lux. The key to remember about measuring in lux, that is a specific point at a specific distance away from a light, and I'm looking at a specific area. So maybe a 1 by 1 inch square area or 1 foot square area. The angle comes into play. Am I holding that lux meter perpendicular to the light? Am I holding it on a little bit of an angle? Am I setting it on the ground so that it's hitting it on a complete angle? That's all going to change the lux reading. So while lumens is the output of that light, lux is the specific point on the ground over a specific area of the light. Not very easy to compare two lights based on lux. We used to always talk about wattage. Wattage was an easy thing for us to understand. I had a 60-watt light bulb in my house. I knew about how bright that was. And if I went to a 100-watt light bulb, it was brighter. Wattage is simply the amount of electrical power that that light uses. And when it came to halogen lighting, the more power it used, the brighter the light. So the more lumens it put out. We didn't really talk about lumens when we talked about halogen lighting, but they did exist. When it comes to LED lighting, we can't directly correlate that. Just because an LED is drawing more power than its competitor doesn't necessarily mean it's putting out more lumens. So while it's important that we know the watts because we need to build our electrical system to properly power the amount of lighting we have, it's not telling us how bright the light is. Color is not something that you have much of a choice of in this industry, but there are different colors for each light on the market. You can measure color based on Kelvin. So you see the numbers on the screen here ranging from 2000 Kelvin to 10,000 Kelvin. What we're talking about here is a warm, neutral, cool, or cold light color. Most of the lighting designed on the market today, the lighting from FRC, is going to be right around that neutral to cool area, that 5,000 to 6,000 Kelvin range. We're looking for something that looks like natural daylight. A lot of your old halogen lighting was more that warm style lighting. So you were in that 2700 Kelvin range. Intensity is looking at a specific pattern. So a lot of people carry a spotlight on their rig, and they'll pull that spotlight off to look at addresses on a house. When you look at a spotlight, typically a spotlight is measured or rated in candela. Candela is looking at an exact pattern or beam and how much intensity is coming out of that. So if I could take the same light with the exact same lumens, but one's a flood and one's a narrow spot, the intensity is going to be different between them two lights. Same light, same source, same amount of lumens, but a different candela because of the pattern. What this really all comes down to, the most critical thing when you're looking at lighting is comparing raw lumens to effective lumens. You have to understand the difference between raw versus effective if you truly want to compare lights in the industry. Both of these terms, raw and effective, are measuring light output. They're both stated in lumens, but they're talking about two completely different things. And understanding the difference between them really makes the difference. If I take the definition of raw lumens, this is the theoretical maximum light output. So if I take my LED and I put full power on it, and if I don't have to worry about anything else, don't have to worry about heat, I don't have to worry about air temperature, I don't have to worry about a lens, how much light does it put out? That's the raw lumens. Say I have an LED that puts out 100 lumens. If I put 8 of them on a board, simple math, 8 times 100 is 800 lumens. I now have an 800 lumen light. That is the maximum light that light can put out. Effective, however, what actually does come out of that light? So we don't live in a perfect world. We do have to shed heat. If we can't shed heat, then we have to derate the light some or it'll burn itself out. We do have losses in our electronics. We do have losses in our lens. All of this adds up to reduce the effective lumens versus the raw. Raw lumens are easy. They're easy to calculate. They're easy to compare. Many vendors will advertise raw only because it makes their light seem brighter. Effective is what you really care about. So professional light manufacturers are going to list both the raw and the effective, which gives you full clarity on what you're purchasing. This chart shows us an example of exactly how this works and how this plays out. So on this chart, if I took two identical lights, let's say they're both 20,000 lumens, in the perfect world with no loss, no lens, those lights would be equal. A majority of FRC lighting, the way we design it, the way we build it, we have 90% efficiency. We're getting 90% of what we say out of that light. Few of our lights have complex lenses, which can have a little more loss. Most of our competitors are only getting about 65% efficiency. So as you see, as you introduce thermal loss, as you introduce optical loss, the effective light coming out of this 20,000 lumen light in the end is drastically different between the two manufacturers. This is what really separates lights in the industry. This gap can be huge. We started off with two lights that were the same. And we said, okay, they're equal. In the real world, what's coming out of the light and going to the ground? The FRC light at 90%, that 20,000 lumen light is generating 18,000 effective lumens. Our competition with that same 20,000 lumen light is generating 13,000 effective lumens. So what started as equal ends up a difference of 5,000 lumens. That's massive when you get out on the scene. Let's shift gears and let's talk about illumination level. Can a light be too bright? Absolutely it can. The brightest light that FRC offers today is a 32,000 raw lumen light. With our output at 90%, that's 28,800 lumens of effective lighting. That's bright. There are situations where you need that. There are situations, and I'm going to show you one, where that's too much. So let's take a look at some of these situations. First example I'm going to give you here is a truck with warning and scene lights activating as it goes down the road. Now look at this truck. Think about if you're approaching this truck on an incident. Those bright white lights that are flashing on and off on the front, very distracting, very bright. Those were the scene lights. And when this truck was first built, they were using the scene lights as part of the warning light package. They eventually turned them off and said, that's not going to work. It's too bright. It's blinding to the oncoming traffic. These are the type of things we need to consider. There's another example with the brow light. Do I need the brightest brow light in the industry? Maybe. But how am I controlling it? When you got on scene with this truck and you fired this brow light on, other trucks approaching the scene were calling and saying, turn your brow off. We can't see. We can't get positioned properly on the scene. Does that mean that I shouldn't have this brow? Absolutely not. Does it mean that this brow is too bright for its purpose? Not necessarily. Think about how I switch it. Can this brow be switched in sections? Is there an intensity control on it? Can I dim it maybe? Having those type of controls so that I can get onto the scene first, have it on bright enough to light up the area but not blind the oncoming units. Now everyone's on scene, the scene's secured and shut down, there's no approaching traffic. Maybe I want to light it up to full brightness. That's fine. These are the little things that we're talking about, considerations on how you're going to operate on scene. This example talks about perspective and angles. Different perspectives can have different outcomes. When I look at this rig, this rig is turned on and I've just positioned the camera in two different spots. When I look at this from the side, both the ground and the step lights are on. I'm lighting the ground up very nice and I'm really not blinding anyone. The step lights, however, when I look at them from the rear, that would be absolutely blinding if I were following this truck down the road and driving behind it. So again, does that mean the step lights are bad? Not necessarily. When do I want them on? When do I want them off? Maybe I need to switch these. So if I had one switch that turned all of them on, that could be a problem. But if I had one switch to turn on the ground lights and a different switch to turn on the step lights, maybe I can flip them ground lights on when I'm approaching the scene so I can look for cornering and positioning, but not blinding people with the step lights. This all leads us to purpose-driven lighting. Purpose-driven lighting is really just getting at thinking things through, not just saying, well, we always threw a light on each side of the body in the middle as high as we could, and we made it as bright as we could. We always put a light on the back of the truck that telescopes, and we made it as bright as we could, and it can be run at any time. Think these things through. Give it more thought and planning. Here's a good example of some lights on a rig as it's operating. Consider the impact. Where will the light go? Light towers up in the air. That's doing a great job of lighting everything up and not blinding anyone. There's a telescoping light on the pump panel. It's perfectly fine. It's a 15,000 lumen raw output light. With effect, if I consider effective lighting, that is an FRC with 90% efficiency. So that's 13,500 effective lumens. I can see the dump tank. I can see the pump panel. I can see the deck gun operating beyond that light. I'm not blinding anyone. That's on a telescoping pole. I can move it around. So in my opinion, this is a good effective use of purpose-driven lighting. It's not too bright. It's not overpowering, but it's doing its job. In this situation, we have the brightest light that FRC makes, our Radiant Max, which is 32,000 raw lumens. That is the brightest one in our portfolio. That means that's 28,800 effective lumens. Now, am I saying we made a mistake by putting this telescoping light in the back of this rig? Absolutely not. If I raise this pole up into the air, maybe tilt that light a little bit, change it around, it's absolutely fine. In the lowered position, it's blinding. Anyone at the back of this rig, when they look at that light, is going to be night blind for a moment. Give some considerations to things. These lights come with an optional raised indicator. That raised indicator is an input that comes into the truck that puts on the little light saying, hey, you left your light up. No reason I couldn't wire that in so that when it's lowered, if I hit the switch, it won't turn on. But if I hit the switch and then raise it, it would come on automatically at that point. That way I'm not blinding people behind me. Just think about these little things when you take things into consideration. Let's talk about a new tech, something new that we've come out with in lighting. So let's think about what we have out there in the environment. What does a street light do? Well, it's built into its name. It lights up the street. Where is the street? Below my feet. It's down on the ground. That's what that's for. Now, inherently, in a town or a city atmosphere, that street lighting, depending on how tall it is probably going to light the first floor of a building next to it. It may even get up onto the second floor some. But anything taller than that, even the top of the second floor, probably is not getting illuminated by the street light. We all have response areas where we typically see a building taller than 2 stories. Even if we're a rural apartment, if someone's got a big barn, first of all, there's probably no street lighting near that barn. Second of all, if there was, it's only going to go about halfway up the barn. So it doesn't have to be a high-rise building per se. It can be any town USA that has lighting that they could use above that second floor level. Traditionally, all the lighting that we designed in this industry was meant to go out and down. So lights on the side of a truck would light up out into the distance and down to the ground, not up. Introduce you to the new FRC Spectra HR light. And don't get caught up in the letters HR. What do they stand for? Well, they stand for high rise. Doesn't mean that this light is only good for a high rise. As I've shown you, it can be used for multiple applications for anything taller than 2 stories. This is a unique light that is designed to position light out and up. All that we've changed here is the lens. This is the same Spectra Max that we've been selling for over a decade at 28,000 raw lumens. That means the circuit board, power supply, the LEDs, the housing. They've been around for over a decade. The only change here are the optics inside the lens. What did changing those optics do? By changing those optics, we're able to direct light around the scene in a different pattern. So here you can see this is an example. If I had this light sitting about 120 feet back from a building, I can light up 6 stories tall by 4 apartment windows wide. That's a massive space lighting up a building. And this graph here is showing you the optics. So I am still directing light to the ground, but I'm also directing light up onto the surface of the structure. I could fix mount this on a rig. I could carry this on a tripod that I sit back off in the distance. And this light, just like all of our Spectra lights, is protected by a lifetime warranty. Numbers are one thing. Charts and graphs like you see on the screen right now are another thing. What really shows us the difference? Real-time applications. Here's our Spectra Max. It's on a tripod in a parking lot at a fire training academy. It's 28,000 raw lumens of output, which is 25,200 effective lumens. This is a 5-story rescue tower in the distance. You can see we're solidly lighting up the ground, solidly lighting up that first floor. We're getting onto the second floor. For reference, I'm going to drop a red line across here. That line is denoting about how high up we're getting really bright, effective lighting. Now I'm going to switch this light off, and I'm going to switch on the Spectra HR. I'll tell you it's set on the exact same tripod, same distance off the ground, same distance back from the building. We're not tricking it. We're not tilting the head up. It's pointed straight, just like the Spectra Max was. Take a look at the difference. Notice I stopped for a minute and didn't say anything because the difference is visually obvious. Still a 28,000 raw lumen light. The effective has dropped a little bit. We're 85% efficient on this light because the lens is more complicated. so there's a little more loss in the lens. Even though I'm putting out technically less light, you can see the effectiveness of it is completely different. I'm going to flip back and forth between these two so you can really see the difference. Not to sound too cliched, this difference is literally night and day. I'll drop our red line on there to show you where that Spectromax stopped. Literally the same exact light. It's just a different lens in front of it. This is what we mean when we talk about purpose-driven lighting or effective lighting. Defining what you want to do with it and then using it the proper way. Now, you have a lot of choices in the industry, and competition is terrific. It's what's gotten us to have lifetime warranties. It's what got us to a no-hole guarantee on the FRC lighting. These are all things you need to take into consideration when you're shopping for your next light. But what makes it difficult is going to competitor A's website, competitor B's website, then the FRC website. And man, this one's selling a sales pitch. This one's talking about lux. This one's talking about illumination. This one's talking about light, raw lumens, effective lumens. It's confusing. It's a lot of info. We've tried to cut through all that noise for you. If you go to rigrecon.com, under topics, go down to scene lighting, click on product guide. You scroll down the page on that product guide, we've provided you comparison charts. These comparison charts show our product and our competition. All the information is taken from everyone's website and gathered into one area. No sales pitch here. This is the size of the light, the raw lumens, the effective lumens, what voltages is it capable of operating on, what's the amp draw, need to know that so I can design my electrical system, what's the warranty. We even give you the model number of our light and our competitors. So if you're using our competitors' light and you say, man, I really like what I heard about the FRC light, I wonder what the equivalent light is. Go to this site and you can find it. Second thing we've done is, it's one thing to look at data like you just looked at there. It's another thing to physically see it lit up in the dark. Back to our rigrecon.com, topic, scene lighting, click on the technical guide. When you scroll down on the technical guide, you will find comparison videos. These comparison videos are all shot on a football field. The lights are in the same exact position, and then we fly a drone. We lay those images next to each other so you can compare them. So in this video, I'm going to compare the FRC Radiant Max to the High-Vis FT. This is the brightest light in our offering at 32,000 raw lumens. I believe, or at least at the time of recording here, this is the brightest light that High-Vis offers at 28,000 raw lumens. It's very critical to look at the effective. Brought this up before. Difference in raw on these two lights is 4,000 lumens. Difference in effective, 28,800 versus 12,290. That's 16,510 lumens different. 4,000 different on the raw, 16,000, 4 times different on the effective. Now I ripped them numbers off and you're going, I don't know, you're losing me. It's just numbers. Look at the proof in the actual light. Look at these two lights. Look at the goalpost and the difference in the distance. Look at the house. Look at the hash lines on the field, the yard markers. 40 yards out lit up, about 25 yards lit up. You be the judge. As we zoom around here, look at the stands on the left and right side. You can tell the difference clearly between these two lights when you put them on the field and you perform. We don't just compare our lights to our competitions. We compare some of our lights to themselves. Again, talking about purpose-driven lighting. So the FRC Spectra 900 series. This is your small 6x4 light, typically mounted on the side of a cab or the back of a body. For years, we had the Spectra 900, designed to put a spot out there. So light into the distance, a little bit down to the ground. After a few years, we looked at the effectiveness and said, well, when you're opening a cab door and you have a light coming on, am I worried about lighting up the address across the street? Or am I worried about lighting up the ground where this guy's going to be stepping down to? That's the difference between these two lights. Identical lights when it comes to footprint, wiring, things like that. Again, look at the video. On the left, you see that spot, and on the right, you see that flood pattern. What am I trying to achieve? Am I trying to light up 25 yards away? Or am I trying to light up 15 yards right down to the ground, but the full hash marks wide? Neither is the right answer. It depends on what you're looking to do. We've taken the guesswork out by showing you these videos. Thank you for your time and attention today and for tuning in. If you scan the QR code on the screen, that will take you to my contact information. It will also send me an email and connect us. If you have suggestions for other things that you'd like to learn about on one of these webinars, please feel free to reach out. You can also go to the Contact Us section on rigrecon.com and fill out the form, and we'll be sure to get back to you. Encourage you to tune into future presentations or previous ones we've done. And when you're speccing a truck, remember, spec the best.